Fine. So today we're going to learn again the programming techniques. So computer supports to write the program in the following four techniques. Fine. So what are those techniques? Let us learn one by one. So first one is procedural programming, structural programming. Okay. And next one object-oriented programming system. And next one is event-driven programming. So let us learn one by one. So here we have procedural programming. So what the main purpose of this? So this programming technique supports to write the instructions directly in a provided environment. Example, so there is some procedure for it. So this is going to allow us to write the instructions in the given environment itself. That is basic, Fox Pro are the examples. So when a program is written using this technique, it follows with the following disadvantages. Readability of the program is lost. You can't read the program because you need to follow a particular procedure for that. Error detection and modification is not easy, right? Then you have to overcome the above listed drawbacks. There are some foundations which are laid for a new programming technique that is called as your structured programming. Is that point clear? So at this programming technique, what you do is before writing the program, right, or before writing the user instructions, few predefined codes or predefined instructions are provided by the software. Okay, and those need to be enclosed. So this is very clear for you. So what you're going to do in this structured programming technique. So before writing a program, user has to just insert some of the predefined instructions. Right. So there are some advantages provided by this structured programming language. Let us go with that advantages first. Right. So these are the advantages. First one is readability of the program gets enhanced. So what are the disadvantages there in that procedural programming? Those are overcome in this structured programming technique. So error detection and modification will be quite easy. So example, C language, COBOL, Pascal, and Fortran. So now we're going to learn what is history of C language. Okay, so let us learn step by step. So in the year when C language was introduced in the year 1960, it was by name Algol 60, which is nothing but algorithmic language, and it was developed by International Committee. And in 1963, it was renamed to CPL, which is nothing but combined programming language. Okay, and in 1967, exactly after 4 years, the CPL has been renamed to BCPL, which is nothing but Basic Combined Programming Language, and it was introduced at Cambridge University. Okay, and the person who has invented this BCPL is Martin Richards. In 1970, it was renamed to B language, and it was introduced by K.L. Thompson. It was done in AT&T Bell Labs, which stands for American Telecommunications and Telegraphs. Okay, in 1972, finally, this B language was renamed to C language, and it was who invented this is Dennis Ritchie, and it was in the same AT&T Bell Labs. Okay, so this is history of C language. Finally, if I say when the C language was introduced, so it was introduced in the year 1972 by Dennis Ritchie and at AT&T Bell Labs. Okay, so in order to write a C language program, there is a particular structure to be followed. Okay, so I'll say you as C language supports to write a program using structured programming technique. So you are going to write some predefined instructions. Okay, so what are those predefined instructions? I'll let you know now. Yeah, you can see here. First of all, you're going to write preprocessor. Next, you're going to have a global declaration. So we have local declaration and global declaration of variables. Then we have linkage section. Okay, and we have main function. In that main function, you're going to insert the compound statements. In that compound statements, right? So you're going to work with two things. That is declaration part where you're going to declare the variables, and you're going to execute uh, execution part where you're going to execute whatever the variables you have declared. You're going to perform some manipulations and you're going to execute them. So this is all about the structure of a C language program. So there are some points to be related to the C language. What are those? C is a middle level language. So this C supports to write a program in not procedure oriented, rather it supports to write in structure oriented. Now C is a compiler oriented language. C is case sensitive. What is mean by that? So program in C language should be written in small letters. Is it point clear? So this is all about your program structure and some points to be remembered to work with this C language, right? So then you have the main important concept, that is representation of data. So what is meant by representation of data? So data will be represented in C language based on some three main key points. That is data name, data type, and data size. Data name is nothing but where you're going to store a data. Suppose if I declare A is a data name where I'm going to store some value into it. Okay. And the data type is nothing but what type of data I'm going to store into it. So this is 10. 10 is an integer. So I can store integer into this variable. So this is data type. Okay. What data type will do? It will say what type of data to be inserted into this variable. Okay. Then afterwards, this is data name, right? And this is data size. Actually, size is nothing but it will be given with uh, the data types like integer, what is the size, for float, what is that size, right? That we'll see in the next slide. Sorry. So just go with these things, right? So very important. Data name, it is called as a variable. I said this data name is called as a variable. Okay. Or identifier, that is called as variable, or it is called as identifier, or it is called as a field. Okay. Data name is one which supports to store the data. So you can see here data name can be with minimum of 1 character and maximum of 32 characters. You can see here I'm going to take int. Okay. So you can see here int a equals to 10. Now here the size of that data as the size is only 1 character, but I can say int total equals to some 100. So here total is of 5 characters. In this way, you can take the name, data name with minimum of 1 character and a maximum of 32 characters. Okay, that's what here it is mentioned. Data name should not hold any blank spaces. There should not be any blank spaces like this. Total equals to 10. So this is again there is blank space here that is not allowed in terms of your C language. Okay. Next, data name should not be enclosed with a special characters except one, that is underscore. You can start your data name like this int underscore a equals to 10. You can start like this, but you can't start plus a equals to 10. You can't start minus b equals to some 20, or you can't start slash equals to slash b equals some 100. So this is invalid, right? It can only just start with only underscore. It can be started with underscore. It should not get started by numerics. So you can't start like this int 2a equals to 10. You can't start with numerics. Okay. It can start either with alphabet or with underscore. Data name can be with a small letter or it can be capital letter. So you can say int a equals to 10 also. This is also valid. Okay. Next. Redeclaration of data name is invalid. See, I can't redeclare this data name once again. Okay, suppose if I've taken int a equals to 10 and somewhere in the program I'm taking again int a equals some 20, you can't declare. Redeclaration is not possible because already a is given with 10 value. Then how can you take again a value? Right, you can't declare that. Redeclaration is not valid. Data name should not be a keyword or that is a keyword of C language. See, we have 32 keywords, right? Example of 32 a few examples I'll say. Int is one keyword. Okay. Exit is one keyword, right? Then you have few more keywords. For is one keyword. So you can't give int for equals to 20. Data name cannot be your keyword. Okay. So this is all about your data name. Okay. So next is data type and data size. So this is very important. What is data type? Data type explains regarding what type of data you're going to store into a variable. Suppose if I declare int a, right? So what type of data I'm going to store in this int a? I can store only integer because a is nothing but it is an integer value. It can store only integer. If I store 10.25, right? So it takes only 10. It avoid or it discard 0.25 because it is a float value. Float value cannot be stored into your integer. So it takes only 10 instead of 10.25. Is that point clear? So that means that if I take float, float of some C. So float C is nothing but it's a float variable, okay, where I'm going to store 10.25. That is valid, right? So this is how this is data type. This is data type. Data types explains regarding the type of data to be stored into a variable. Clear? Fine. So I can say that data types are derived into two categories. First one is primary or primitive data type. Second one is your secondary or derived data types. So primary data types you have integer, character, float, double, right? So void, all these are your primary data types. Coming to secondary data types, arrays, structures, unions, pointers, enumerated data type. So all these are your secondary data types. Okay. So let us learn them individually. So just come with your integer. So what does this integer do? This integer, this data type supposed to store, right, the data which is of purely of numerics. Okay. It's supposed to store positive value, it's supposed to store negative, and it's supposed to store zero also. It is represented with a keyword called int. Integer is always represented with a keyword called int. Okay. And the default memory for it is 2 bytes of memory. 2 bytes is nothing but 16 bits. 1 byte equals to 8 bits, as we have seen in the previous session. So 2 bytes equals to 16 bits. Okay, so maximum value which you can store with this data type is minus 32,768 to 32,767. Right. So integer data type is derived into following categories. It is of signed int, which is given with percentile d. It is of unsigned int, percentile u, short int, and long int, but that is percentile ld. Okay. Then you have character, which is always character is one more data type. Character is represented with a keyword called char. Okay. And by default, it occupies 1 byte of memory. Memory allocated for this is 1 byte, which is nothing but 8 bits. So maximum value you can allocate for this character is minus 128 to 127. Okay. So character data type is derived into two categories. That is signed character, which is percentile C, unsigned character also percentile C. Is that point clear? So this is the data type for integer and character. Then we have float, void, double. Okay. Let us learn them as well. This is float. Okay. Now what you do here, this data type supports to store the value which can be purely of numerics. It can store integers, it can store decimal values, or it can store both, that is real value. Just see here, I'll declare float a equals to, I can store 10. So if I print this value, printf percentile f. So what is this percentile f? I'll say you in coming classes. If I print this value of a value will be printed with 10.00. Even though this is 10 integer, you can allocate integer to float value, but by default, it is going to print 0.00. If you assign 0.25, so it is going to print 0.25. Is it point clear? So now by default, float is always represented with a keyword called float. By default, it allocates 4 bytes of memory, which is of 32 bits. Okay, so maximum value you can store is minus 3.4 e power 38 to plus 3.4 e power 38, which is nothing but 34 into 10 power 38. So these many numbers you can store into this float value variable. Okay, then you have print print statement, which is your output statement. This is your output statement. Okay, and you have scanf, which is your input statement. Is it point clear? So this is how we are going to just take these two things. Printf, it is in this function, f stands for formatted. You have printf. This f stands for formatted. Okay, so what it will do, it is an output function. It displays the messages and memory values. Just now we have just seen here, you have printed this. It is displaying the value. So it displays that memory values. So syntax, message. Okay, you're going to write some message. Then you're going to give escape sequences, conversion character, and list of variables. Example, I'll say you're going to write like this. Printf. Okay. Then you're going to have message like value is okay. Then you have escape sequence. Escape sequence is in nothing but next line, right? Then followed by conversion character. So this is not here. One second. Conversion character is nothing but if you want to print integer, you're going to take d as your percentile d as your conversion character. Then list of variables, semicolon, you're going to close list of variables, whatever the value you want to print, you're going to print like this, followed by semicolon. So this is output function, printf. Then scanf is nothing but it is an input function. It is used to accept the input from the user at the execution of a program related to variable declared with different data types. So input will be accepted by this. Okay. Syntax int a. What is the syntax? So escape sequence, conversion character, list of variables. Right? Example scanf percentile d. If I want to take a value, it is going to you are going to say this ampersand. Ampersand is nothing but address operator. Okay, so here you're going to now see here what I've taken a equals to 10.25 by default I've assigned a value. But if you write ampersand a, system will ask us a value to give. So a value I can give some 100.25 like this. So at the time of running the program, you're going to give this value. Here it is by default, it is a constant value. Is it point clear? So now this is all about your printf as well as scanf. Based on this, we have many programs coming forward, right? So just concentrate on all those programs that will help you out in cracking your interviews because I have covered a lot of programs. Okay. In these sessions, you are going to see how many programs we have covered and what way we are going to work with them. Okay. Make sure you'll just listen all these classes. Okay. So before writing the program, you are going to just uh, define few of the points. So every program must be enclosed with structure specified by C language. Every program can hold a maximum of only one main function. Okay, there can't be any two main functions. Every statement in C language should be terminated by semicolon except main. For main, there should not be semicolon. Except main, there should be semicolon for all the what you can say statements which are enclosing in C language program. Whenever program is modified, it should be compiled. When you just modify the program, definitely you have to compile because the changes to be reflected, right? So if you don't compile the program after modification, changes won't be reflected. Program can be executed any number of times. Okay, I said just now we have some escape sequences, so these sequences provides their output at their execution of the program. These escape sequences are preceded by backslash. Just now we have seen. So backslash n, which is nothing but new line or next line. Backslash t, blank spaces, 8 blank spaces. Okay, tab. Okay. If you press backslash a, it is going to give you a beep sound. Backslash b, which is backspace, right? Backslash r, this is carriage written. Backslash v, this is vertical tab. Backslash f, form feed. So in this, we are going to work with the first one, backslash n, if possible, backslash t, and this one we can say backslash v sometimes. Only three, but maximum we are going to use first two. And out of these first two, first one is very frequently used. Okay, fine. So just go with these next topics. Fine. So just see here, we have three types of errors. Okay. So what are those errors? We have compile time errors, we have runtime errors, we have logical errors. Okay. So what are compile time errors? So compile time errors are errors which occur at the compilation of a program. It includes syntax errors, right? While compiling the program, like semicolon missing, comma missing, inverted commas missing, program is not written as per the syntax of the structure of the program, then you're going to come across this syntax compile time errors. Okay, so when these errors you come across, what you'll do, you'll go back to the program, you'll go back to the program, okay, you can modify the program and you can re-execute the program. Then you have logical errors. Just keep this aside. Okay. Logical errors. So logical errors are nothing but just see a equals to some 5 I have taken, b equals to some 5 I have taken. If I say a plus b, the value should be 10, right? But internally, after printing, the answer I'll get as 25. So what is that? What is my expected output? 10. What is the output I got? 25. Is the expected output and output which I got are not matching, right? So I'll go back to the program. I'll check, okay, instead of plus A into B has been done. That's the reason I got this. Okay. So this is how we are going to work with. Then you have, so there is a logic in the program. So in the error in the logic of a program, right? So when your output which you expect and the output which which you get does not match. Okay, so uh, this is all about your logical errors. Then you have runtime error. Okay, so runtime errors will occur at the execution of a program. So when you come across compile time errors and logical errors, you can get back to the program, you can modify the program, and you can re-execute the program. But when you come across these runtime errors, there won't be any re-execution of program. The program gets terminated there itself. Okay, this is how we are going to just go with. Okay, so runtime errors can't be modified or can't be handled. So in Java, you have a special concept called exceptional handling where you're going to just handle these runtime errors. Okay, so just a sample program. Okay, just see here. Write a program illustrating the use of output statement. So this is hash include std. What is that? I'll say you. Then your main function clears the screen. Everything I'll explain you in bit by bit. Okay. Printf welcome to C language. Then you're going to just printf thank you. So the output will be welcome to C language. In the next line after tab. Okay. You're going to print thank you. This is all about the concept. Okay. Fine. So we are here, right? So here we have this hash include stdio.h. Okay. What does this stands for? Hash include stdio.h. So this is your header file. Okay. Hash stands for preprocessor. Very, very important interview question. Okay. What does this hash stands for? It is a preprocessor, right? Then this stdio.h is an header file. And what is this stdio.h? It stands for standard input and output. Okay, so in order to work with our input output functions, we are going to enclose this header file in my program. That's what I have enclosed here. That is standard input output header file. Then main function. So very, very important. One more interview question is whatever the programmatic language, it is either C, C++, Java, the program execution always starts from your main function. So this is main function. Then clears the screen. So CLR, SCR, which nothing but clears the screen, you know that. Okay, what does this do? Suppose if I've done one program and I got the output as some hi, I've written some program and I have written hi. Okay, I have printed hi with that. And next program I have done, I have written hello. I've printed hello. So if I don't specify this CLR, SCR, okay, that is clears the screen. If I execute this second program, the first program output also appears on the screen. So if I print or if I use the CLR SCR, it means that whatever the output which is there previously, all that output will be erased and you're going to get a new output. That is the main purpose of clearing the screen. Then you have printf. As I said, printf is going to print the value or print the message onto the screen as an output. So here it is going to print welcome to C language and every printf statement or every scanf statement or every statement in C language should be terminated by semicolon like this. Okay. Then again you're going to print printf thank you. So backslash n stands for next line. So how the output will be, you can see here, program execution starts from your main function. First, it is going to print welcome to C language, right? After that, you have backslash n. So cursor comes to next line, okay? And backslash t after spaces, after tab, okay? It is going to print thank you. Sorry, programs. So what I'm going to do with this for second program, sample program, write a program to find the sum of two numbers. So what is that? I'm going to take a value. I'm going to take b value. A value, I'm going to take something. B value, I'm going to take something. I'm going to calculate sum of two these two. So for storing values, I need two variables. And for storing the answer that is resultant, I need one more variable. So totally there is a requirement of three variables. So what I've done, hash include stdio.h, hash include conio.h. Conio stands for console input output header file. Okay. So generally we use get ch, getting one character, right? So for that thing, you're going to use this conio.h. Okay. So just see a program. First, I'm going to work with main function, right? So I'm going to declare three variables, A, B, C. Okay. A is to store one value, B is to store one value, C is to store the resultant as we have discussed. Clears the screen. This is the structure you need to follow. First of all, declaration section, right? Afterwards, you have clears the screen. Then you are declaring the values, assigning the values to the variables. A equals some 25, B equals 20, C equals to some, and the answer will be like this. Sum of two values, which is written in inverted commas, right? So whatever you write in inverted commas, that will be printed on the screen. Okay, just see here. So how the output will be, the first output will be like this. Sum of two values is, instead of this percentile D, this is used for integer, right? So C is an integer. If A is 25, B is 20, this C will be 45. 45 is an integer. So for integer, the conversion character is percentile D. So it is going to print a C value instead of this percentile D, which is, what is that? Backslash n. That is in the next line. It is going to print the value of C as 45. Is that point clear? Then afterwards, okay, next line again. This is one more thing. See, one more way of working with this. So just see a percentile D, very important, percentile D plus percentile D equals to percentile D. What is the meaning of this? Here you have written ABC values. So first percentile D is for A value, second percentile D is for B value, and third percentile D is for C value. So this is A plus B equals to C. Instead of these things, it is going to write 25 plus 20 equals to 45. This will be the answer for this second statement. Okay. Then sum of percentile D and percentile D is percentile D. That is ABC. That is in the next line. It is going to write sum of, first percentile D is for A. Sum of 25 and second percentile D is for B. 25 and 20 equals to, sorry, yeah, is there, right? Is percentile D. This percentile D is for C value, which is nothing but 45. So this is how we are going to print. This is first print statement. This is second print statement. And this is your third print statement. Okay. So variables. So here you can see variable supposed to store maximum of one value. If more than one value is stored, last value will be given a priority. Suppose A value is 25, B value is 20. Again, if I declare A value as 45 after this B, right? So A value will be 25 initially. This is A, which is 25. That will be overridden by this 45. So the new A value will be given with 45 value. That's the last value will be given priority. Okay. Now next thing, the same thing. As we have done sum of integers, you are going to write a program for doing sum of two real numbers. That is float ABC. See, real numbers are nothing but float values, right? 10.25, so right, 20.75, which is nothing but 31.00, like this. Okay. So point values, real values. Okay. Just see here. Float ABC, three variables. Clears the screen. A equals to 12, same thing. C equals to A plus B. Sum of 2F and 2F is 2F. So 2F is nothing but after point, it is going to take two decimal values. Is that point clear? If I don't specify this 2F, it is going to take some more than like this. Okay. So it is going to print sum of this one. What is that? 10.25, and so here it is 12.27. Sorry, 12.27, and second 2F is 14.32, is third 2F. C value will be printed over here. Get CH end of the program. Okay. So you can see here, when only percentile F is specified, it displays six decimal values, this six decimal places like this. 1, 2, 3, 4, 5, 6. If you specify as percentile F. So if you specify it is percentile 2F, after point, it is going to discard all these. is going to print only first two uh, values after a decimal, that is point. Okay, this is how generally you're going to work with the program. Okay, so why I'm saying all this, because these are set from scratch so that you'll understand each and every point. So my point is making you understand from starting to end, right? Now this is a simple question, a simple program where you're going to find the sum different products of the two values. So this is A, B, two values you have taken. Sum will be stored in S, difference will be stored in D, product will be stored in P. Clears the screen, main function, right? You can enclose two header files, hash include std2.h, hash include conny.h. A equals to 5, B equals 2. So I'm going to calculate sum. Sum equals to A plus B. Difference A minus B. Product A into B. Now sum of percentile D and percentile D is percentile D. That is 5 and 2. 5 and 2 is 7 will be printed here. Okay. And the next line, difference is, right, difference of percentile D and percentile D. Difference of percentile D is nothing but difference of 5 and 2 is 3 will be printed. Right here, 5 into 2, 10 will be printed. Is it point clear? 5, 2, 10 will be printed in this statement. Right. Now next is coefficient of two values. Okay. So you're going to print the coefficient. The coefficient is nothing but if you do division, you're going to get the coefficient. Right. If I take int AB, suppose here I have taken AB values. A value I have taken as 22 and B values I have taken as 7. Okay. And float C. Why I'm doing this? Because just see here, C equals to A plus B, right? Sorry, A by B. C equals to A by B is nothing but 22 by 7. If I do 22 by 7, I'm going to get around 3 point something, 3.1 like that. Okay. So 3.1 is nothing but it is a float value. So if you take float C, you can store this float value here. But if you take integer here, you can't store float value into it. It will store only 3. It won't store zero point 0.1. Okay, that's the reason I'm going to take float C. C equals to A by B. And I'm going to print the coefficient. Whatever the coefficient I'm going to get, I'm going to print here with this C. Division of 2 and 7 is 3.00 something. Okay, not 3.00, it will be around 3.1 something. Okay, fine. So this is all about coefficient of tokens. Like this, you have many programs. Just I'll go with sample programs. Wherever we find some important that need to be specified, I'll focus much on that. Okay. Meanwhile, hope you got all these things. So this is a logic you're going to maintain, right? So if you do integer by integer, the answer will be integer. Suppose 10 by 10, the answer will be 1. Okay. If you do integer by float, the answer will be float. Integer is 10. Okay. And float value is some, what you can say, 5.1. If you take like this, right? So answer will be around 5 to like around 1.9 like that. Okay. 1.9999. 1.999. So you're going to get float value. If you do integer by float, you're going to get float value. If you do float by int, 10.2 by 2, right? So which is nothing but 5.1. So which is float, right? Float by float is always float, right? 10.2 by 5.1, which is nothing but 2.1. Is it point clear? So this is how generally you're going to work with these things. So now this is typecasting, very important interview question as well. What is typecasting? Name itself suggests type is nothing but data type. Casting is nothing but converting. So conversion of data from one data type to another data type. So integer will be converted into float. Float will be converted into something else. So that is conversion of one data type to another data type. Example, you can see here in int a comma b, float C clears the screen. A value is 22, B value is 7, C value equals to 22 by 7. Okay, 22 by 7 is nothing but we are going to get around 3.1. Okay, now 3.1. See, now why I'm doing this is just take this concept. If I do integer by integer, the answer should be integer, right? If I do integer, 22 is an integer, 7 is an integer. Integer by integer, the answer is integer. But why you are trying to store the answer into float? Is it point clear? So that's the reason I need to convert either numerator or denominator to float. So I'm going to convert this numerator float of a by b. A is converted into float. Is it point clear? So this is how I'm going to just convert this. Either I can convert this a as float or I can convert b as float. Either one can be converted to float. You can see here. Either this one can be converted to float, either denominator can be converted into float. Right. So remaining all things as normal, right? Just see here, float a comma b, a equals to 12.34, b equals to, what I'm doing is b equals to, I'm storing int of a. Int of a is nothing but a value is 12.34, but I am storing only integer part of this a, which is nothing but 12. So b is nothing but 12. That will be, just you can see here, and that is float. So 12.00 will be printed over the screen. Hope this is clear, right? So these all few things. Integer plus integer is integer. Integer plus long is long. Long plus integer is long. Long plus long is long. So all these generally we are going to work around. That's it. Okay. Now in the previous examples, what you have done, a value you have assigned with some value, b value you have assigned with some value. If I do the program, a value, see, suppose I am saying in a class a program 10, a equals 10 and b equals some 20. If you copy the same program, whatever the values I give for A and B will be same. Whatever the values you take also for this A and B will be same, because these are constant values I have assigned, you have copied. Right. Now, someone wants, I don't want A value as 10. I want B, I need to try with a new value that is 100 and B value some 200. Someone wants A value as some 6, B value as some for 2, like that. So user required values. So user required values, in order to get that user required values, we are going to use the concept of scanner. So system is asking us a value to enter. Just see here, int ABC clears the screen. So main function is common. Enter first number. Scanf percentile d. A is an integer, right? So you're going to use percentile d as conversion character and ampersand A. So now system is asking us to enter a value. I'll enter 100. You people will enter 1000. Someone will enter 6. Someone will enter 10. User required values. Then afterwards, enter a second number. So a second number, I'm going to enter some 200. C equals to A plus B. 100 plus 200 will be calculated and C value will be printed. Get CH, end of your program. So what is the main purpose of this get CH? It is going to get one character from the system, right? It's going to read one character, right? So generally, if I compile the program, I'll say Alt plus C, that we have seen in the previous class, right? So this compiles the program, okay? If I say Alt plus R, it is going to run the program, right? It is going to run the program. And if I want to see the output, then I can say control plus F9. If I press this, I'm going to see the output. Okay. So instead of this pressing this one, if I write get ch, after I press Alt R, immediately program will be run and output will be displayed. No need to press this control F. It is going to read one character internally and it is going to display the answer for us result. Okay. Hope this is clear for you.